So in this video, I want to just do an example of solving a second order differential equation that corresponds to a forced harmonic oscillator. I'll just point out that the techniques that we're doing work for any of the second order differential equations of these types that are linear, constant coefficient, non-homogeneous differential equations. However, if we are talking about a harmonic oscillator, the coefficients in front of y and y prime here will be positive. Okay, because remember those were originally the negative b, the negative damping coefficient, and the negative k, the negative spring constant, and then added over to the other side. So mathematically, the techniques work even if these numbers happen to be negative, but in terms of harmonic oscillators, we'll always see scenarios where those are positive. Okay, so I want to solve this, so I know that my general solution is just going to be y sub h plus y sub p. So solutions to the associated homogeneous equation and then a particular solution. So let's start by finding y sub h. So the associated homogeneous equation is just y double prime plus 4y prime plus 3y equals 0. So the characteristic equation would be s squared plus 4s plus 3 equals 0. That's going to factor as s plus 1 times s plus 3 equals 0. So s is negative 1 or negative 3. Okay. Now, that tells me that my solutions to the associated homogeneous system are just a copies of e to the negative t plus b copies of e to the negative 3t. Okay. So very, very quick to get that. Not quite as quick as with the first order scenario where we could just do it by inspection, but pretty fast. So a and b here are my arbitrary constants. So I'm going to have a e to the negative t plus b e to the negative 3t. And so now I need to get a particular solution. And we're going to do exactly what we did in the first order case, which is we're going to guess. The book at this point does introduce some fancy terminology to make it sound like we're doing something more sophisticated than guessing. They call it using the method of undetermined coefficients. So my guess is that a particular solution will be a copies of e to the negative 5t, a being my undetermined coefficient. I'm not claiming that all multiples of e to the negative 5t will work. I'm just guessing that a multiple does. So we are still guessing, but if we want to sound more sophisticated about it, we can say we are using the method of undetermined coefficients. Okay, so let us determine what this undetermined coefficient is. So notice yp prime would just be negative 5a e to the negative 5t, and yp double prime would then be 25a e to the negative 5t. Okay. So what I need to do is plug that in so that I can solve for a. So if I do that, we'll have 25e to the negative 5t plus 4 times yp prime would become actually negative 25a. 25a copies minus 20a copies of e to the negative 5t plus 3 copies of my particular solution, so that would be plus 3a copies of e to the negative 5t, and I need that to equal e to the negative 5t. Now both sides are just some e to the negative 5t's. Let's see how many we have. Here, obviously, I have just one copy on the right-hand side. E to the negative 5t. How many copies do I have here? 25a minus 20a plus 3a. So let's see, that looks like that's going to be 8a copies of e to the negative 5t has to equal 1 copy of e to the negative 5t. Okay, and that means that 8a has to equal 1, A has to equal 1/8. So my particular solution now I know is 1/8 e to the negative 5t. Okay. Now, I wrote down both sides of the equation here. That's totally fine because I'm not trying to prove it. I'm trying to solve for A to make it true. I've made an educated guess that it will be true for some value of A, and I'm just solving it. Perfectly acceptable to write both sides of the equation and then solve for A. Also perfectly acceptable to just work with the left-hand side and the right-hand side separately and then say, hey, now I need to equate like coefficients. Either way is fine. It's only in proving things that you have to work with one side of an equation at a time if you're trying to prove that that equation is true. All right, so this will be plus 1/8 e to the negative 5t. So notice in the particular solution, we'll always have specific constants. It's only in the solution to the associated homogeneous that we get arbitrary constants, in this case, A and B. All right, so, oh dear, this almost looks like they're fractions. I didn't mean for that to be a fraction. I just meant to label that this was y sub h. I'm not dividing by it, and I meant to label that that was y sub p. Okay, fabulous. We'll come back with another example in a minute.